In this video, we are going to extend on our knowledge of electron configurations and orbital filling diagrams and talk about valence electrons and how they relate to dot diagrams. So in this unit or in this video, you should be able to write electron configurations, draw orbital filling diagrams, and also be able to give dot diagrams for an element. You should also, at the end of this video, be able to determine the number of valence electrons in an atom and relate this to the location of that element on the periodic table. And then finally, be able to explain why elements on the periodic table have similar chemical properties. So, if we talk about valence electrons, remember, are the electrons that are found in the outermost energy level. Okay, and they are the electrons that are the farthest away from the nucleus. So if I were to look at my energy level diagram, and let's say I filled it in like so, okay, these two electrons here would be considered the valence electrons because they are the electrons that are the farthest from the nucleus. Okay, the valence electrons are the most important electrons in an atom because they are involved in chemical bonding, which we will get to next term, and they are also responsible for giving atoms their properties, okay, which we will talk about in our next unit. The number of valence electrons an atom has can be determined by looking at the electron configuration or the orbital filling diagram. So if we look at sodium, okay, and this is going to be a little bit of a review from writing electron configurations, but if we were to look at sodium, we know sodium contains 11 electrons. So if we fill in our orbital filling diagram, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, from there, we could end up with an electron configuration that looks like this: 1s2, 2s2, 2p6, 3s1. And if we were to draw the orbital filling diagram, my orbital filling diagram would look like this. So the outermost electrons, or the number of valence electrons in this sodium atom, can be determined by looking, number one, at the electron configuration and saying, okay, well, the highest energy level that sodium fills to is the third, and in that third energy level, there's one electron, so sodium must have one valence electron. Okay, we can also come to the same conclusion by looking at this orbital filling diagram, and in my orbital filling diagram, I see only one electron there, so I must have only one valence electron. Okay, so that's sort of the long way of determining the number of valence electrons. There's also an easier way. Okay, we can determine the number of valence electrons by looking at the location of the element on the periodic table. Okay, so if we look at our periodic table, first thing we want to recognize is that our periodic table has different groups. Groups are those elements that are found in the same column, and the group numbers are labeled at the top. Okay, so here we have group 1A, group 2A, group 3, 4, 5, 6, 7, and group 8A. Okay, these middle elements here, we're not going to worry about the numbers, and for now we're just going to refer to those as the B elements. But if we go back to our sodium example, we already established sodium has one valence electron. And if we look at the location of sodium on the periodic table, we will see that sodium is found in group 1. Okay, now that is not a coincidence. What we can see is that the group number of an atom is always going to equal the number of valence electrons. So all of the elements in group 1A will have one valence electron. All of the elements in group 2A will have two valence electrons. Okay, we don't count that for this middle section here, but then all the elements in group 3A will have three valence electrons: 4, 5, 6, 7, and 8. Okay, 8 valence electrons is the maximum number that any element can have. And we'll see that this last column here then are the only elements that have those 8 valence electrons. Okay, the fact that elements that are in the same column, like sodium, potassium, rubidium, have the same number of valence electrons can explain then why those elements have the same chemical properties. And again, we'll look more into that next unit, but we're going to see that all elements that are found in the same column have the same chemical properties, and again, that can go back to this understanding of elements in the same column are going to have the same number of valence electrons. Okay, so the last thing then is we can use a dot diagram as a way to kind of show the number of valence electrons for an element or an ion. So going back to sodium, again, we know sodium has 1 valence electron. Okay, so in our dot diagram, we're going to start by writing our element symbol, which in this case is Na, and we're going to draw a dot to show the fact that sodium has 1 valence electron. So if I just put a dot on sodium, I would get 1 valence electron. That is the dot diagram. If I were to look at something like oxygen, okay, if I look at oxygen on my periodic table, I will see that oxygen is found in group 6A. Okay, so that means it has 6 valence electrons. So if I were going to draw the dot diagram for oxygen, I would draw the element symbol. Okay, we want to think about it as sort of being in a box, so we're going to put 1 dot on every side first. So 1, 2, 3, 4, and now I can double up, 5, 6. Okay, and so my dot diagram for oxygen, I'll make that a little clearer here. My dot diagram for oxygen should look like this. 1, 2, 3, 4, 5, 6. Okay, so dot diagrams are just yet another way in which we can show or represent the valence electrons in an atom.